Now we're asked to find the year during which the populations in both cities will be equal. So we want to get when the population of the city of Sapphire is equal to the population of Avalon. So we already got the equation for Sapphire. We figured out that our S was 1.1. So our equation for Sapphire is going to be 1.1 e 0.1 t by 10 to the power of 6, and for Avalon we figured out that k was minus 0.05, so we're going to let that equal to the Avalon one, e minus 0.05 t by 10 to the power of 6. So we're going to have to solve this for t. So we could divide both sides by 10 to the power of 6 and they will cancel, and then we're left with 1.1 e 0.1 t is equal to 3.9 e 0.05 t. And what we can do now is, say if we want to just get the e exponential by themselves, so what we could do would be we can cross multiply. So say if we divide both sides first by 1.1, so that'll cross over, then we're left with e 0.1 t is equal to 3.9 e over 1.1 e minus 0.05 t, and then we can divide both sides by e minus 0.05 t, so then e minus 0.05 t, and we'll just get us more space. So then we've done that. We have e 0.1 t over e minus 0.05 t, and they cross off, and then it is equal to 3.9 over 1.1. So now we're going to have to go back to our laws of indices. So with the natural exponential function, it's the same for all exponentials. So say if we have something like a to the power of p over a to the power of q, that's going to be equal to a p take q. So this is the same. So this is going to be equal to e, so the first one on top, 0.1 t, so minus 0.05 t, and that's equal to 3.9 over 1.1. That's going to be minus, that's going to be a plus, e 0.1 t plus 0.05 t, and that's equal to 3.9 over 1.1. So then we have to just add 0.1 and 0.05, so then we get e 0.15 t, and then we can write this part here as 39 over 11. So now we have an exponential, but to solve this we need to have it as a log. So if we have an expression a to the power of y is equal to x, we can write this as log a x is equal to y, because at the moment we can't figure out what t is, but we can write that as log e, or that's also the same as natural log. So in this case our x is equal to this here, so we're going to put x on this side, so 39 over 11, and equal to y 0.15 t, so that's the same as natural log 39 over 11 is equal to 0.15 t. So I'll work that out. So natural log and 39 over 11, and whatever I get for this answer, I'm going to divide it by 0.15 0.15, so I'll get t by itself, so 0.15, and then I get my answer. T is 8.43777758, but it said find the year, so they want to get the year in which the populations will be equal. So this is going to be they'll be exactly equal at 3.48 approximately 44 if you're to round it. So if we go back to our years, we got the beginning of 2010, t equals 0, and then we got down to 2016 is t equals 6. So 2017 is t equals 7, and 2018 is t equals 8. So this is in between 2018, where t equals 8, and 2019, where t equals 9. So between the start of 2018 and the start of 2019, so the year is going to be 2018. During that year, both populations are equal. So then the next part of that question, we're asked to find the predicted average population in Avilan from the beginning of 2010 to the beginning of 2025. So if we're going, so when we see average, this isn't exactly logs, this is involving so calculus, so we're going to have to use integration. So our formula, so we have the amount of time. So from the beginning of 2015 to the beginning of 2025. So the beginning of 2010 to the beginning of 2025. So the beginning of 2010 is t equals 0, and then when we get to 2025, it's going to be t is equal to 15. So the amount of years we'll have gone up is going to be 15 minus 0, so it's going to be 15. And then it's going to be 15 at the start and 0, so then 3.9. So we're going to do, so our function for Avilan is 0.05t by 10 to the power of 6, and I'm going to have to integrate this. So 1 over 15. So for integration with logs, so if I was to integrate this e 0.05t, I would get e 0.05t, but it would also be multiplied by minus 0.05. So if we want to figure out how could we have got this, well, the only way we could have got it is if we had 3.9 and 0.05 on the bottom, because then when we multiply it, that 0.05 will cancel out, and then e 0.05. So and 0.05, and so that's going to be by 10 to the power of 6. So it's going to be when t was equal to 15 minus when t was equal to 0. So 3.9 over 0.05. So e minus 0.05, 15. So 3.9, and then what we can actually do is subtract our, I'll go on to another page. So I'll go from here, so 3.9 over minus 0.05 e 0.0515, and then we're going to be subtracting when t is equal to 0. So 3.9 over 0.05, and then e minus 0.05 and 0. So we're getting the average. So if we're to work, and then at the end we have to multiply it by 10 to the power of 6. So to get the average, we're going to subtract these, and when we do that, we get 2.743694 by 10 to the power of 6, and that gives us 2743694. So that's our average over those 15 years. And then the next question we have there is, so using the function, so this is the function for Avalon. So this is our function for Avalon. So Avalon is qt 3.9 e minus 0.05 t by 10 to the power of 6. We're trying to find the predicted rate of change. So rate of change, we're going to have to use differentiation. So at the beginning of 2018. So we want to get the predicted rate of change. So if 2016 is t equals 6, 2018 it's going to be t is equal to 8. So we have to differentiate this, and then at t equals 8. So if we want to differentiate this, so say if we do this part first, 3.9 e and then 0.05 t. So this is all being multiplied together. So by 10 to the power of 6. So that's our expression. And then, well, the only part that has t that we're going to have to differentiate is this part here. So if we're to differentiate this, we get, so if we keep what we got there, if we differentiate that, we're going to get the exact same thing back. But we're also going to have to multiply it by the differentiated form of this here. And if we're to differentiate 0.05 t, we get minus 0.05. So we're multiplying this all by minus 0.05. So then what we get is so it's minus 0.05 by 10 to the power of 6 by 3.9. So minus 0.05 by 10 to the power of 10 to the power of 6. And so when we do that out, so we can actually just write this as minus 0.05 and then our original function, so 3.9 e minus 0.05 t by 10 to the power of 6, but we said we wanted to get it at the start of 2018, so that's when t is equal to 8. So minus 0.05, 3.9 e minus 0.05, and t is equal to 8 by 10 to the power of 6. And then when we work that out, we get, So minus 130,712.409. So we want to get the predicted rate of change. So we're going to have it as a whole number, 712. So that is our predicted rate of change for that question.